Okay, so welcome to lecture 6. It's entitled Numerical Integration. Numerical integration. So you should be able to use the Trapezoidal Rule, Midpoint Rule, and Simpson Row at the end of this lecture. Now, for numerical integration is an approximation of some integrals. Okay, we just look and find ways of approximating definite integrals. So we first start with the Trapezoidal Rule. Okay, so this actually was formulated from the trapezoid. Oh, sorry, the trapezium. Yeah. So from the trapezium, that's how we came up with the trapezoidal rule. So let's have a sketch. Okay, suppose we have a curve. Okay, and we want to find the area under this curve. So we can have that. We can take some okay, so that means we can have okay, no, that's not still nice. Okay. Okay, and then we can form some kind of trapezium. Remember? A trapezium is in that form. Okay. So we just here we're showing that this ranges from A to B. Okay, so we have x is equal to A and x is equal to B. So we're saying that we can form, say, y1, this is y1, then this is y2, and that one is y3. Okay, these lines that are going up there. So what we're saying is that the distance between each of these lines, okay, so D, actually you find that these lines are just equal, the spaces in between, okay, they are equal and defined by D. So D is just B minus A divided by the number of intervals. Okay, the number of intervals that we have. So that is how we get the D. So we have our ordinates. So these are just the y coordinates. The y ordinates we call the y coordinate, we call them ordinates. Okay, so therefore we have y1, y2 up to yn. Okay, so the area here, area under this curve is just given by half sum of the parallel sides parallel sides multiplied by perpendicular distance between them. So this is how we find the area, but in a formula, this is just saying AB of a function y dx is approximately, so that's the symbol for approximation, is approximately given by d open brackets half y plus yn plus 1, so this is the last n plus y2 plus y3 plus yn. Okay, so what we're just saying is that to find the area for a trapezoidal rule, you get the distance, which is the width, multiplied by half multiplied by first and last ordinate, then plus the sum of the remaining ordinates. Example. Use the trapezoidal rule with 4 intervals to evaluate this integral. Okay. So our A is 1, B is 3, and our N is what? 4 intervals. So D is just B minus A over N, which is 3 minus 1 over 4. And gives us 0.5. So that means our x coordinates for x, remember we're beginning from 1, so we have 1.0, then next add the 0.5, the next will be 1.5, then 2.0, then 2.5, and finally 3.0. Okay, then we find the y value according to the formula that is given. Y is equals to 2 over square root of x. So now we make a table. So for x, which is 1, we get a 2. X, which is 1.5, the y will be 1.633. So just replace your x with the value that is given, and that is how we're finding these y's. 2.0, we have 1.414. 2.5, we have 1.265. And for 3.0, we have 1.155. Okay, so according to the trapezoidal rule, the integral 1 over 3, 2 square root of x dx, we get, okay, so we are approximating here. So we put 0.5, which is our distance. Okay, then we're going to multiply by, we have half, the first and the last. The first is 2.0 plus, okay, let's put 0.0. The last one is 1.514. 155. Then we add the remaining 1.633 plus 1.414 plus 1.26. And so we add the remaining y values. Okay, and this gives us 2.945. Correct to 3 decimal places. Okay, so that is how we use the trapezoidal rule. Okay, so I'm sure, please solve the other questions in the module. That will just help us understand fully the trapezoidal rule. Okay, so we're now going to move to the midpoint rule. Okay, so the midpoint rule, here we still have a curve, we're still approximating. So we want to see how we can find this area. Okay, so we have a similar case of what we had earlier, and we have our curve there. So we can have our x, so what we are saying is that we get the midpoints. The midpoints help us to find our y1. There we find our y2. There find our y3, and on that middle there we find our y4. Okay, then the distances here are equal as well. So we have D. Okay, so here the area so we find the y using the midpoint. Okay, so area for midpoint is just D multiplied by y1 plus y2 plus up to yn. So it's just the width multiplied by the y ordinates. Okay. So the y coordinates are also known as ordinates. Okay, let's see how we find that. Use the midpoint rule with 4 intervals. To evaluate correct to 3 decimal places. Okay, so here Our A is 1, B is 3, and our N is 4. Let's find our D. D is still A plus B minus A over N. 3 minus 1 over 4, which gives us 0.5. Okay, so the x coordinates for x, we have 1. Remember, it's starting from 1. Then when we add 0.5, we have 1.5. Then we have 2.0, 2.4, 3.0. So then we say we now find the midpoints. For x. So between 1 and 1.5, what is the midpoint? So x1 will be 1.0 plus 1.5 over 2, which is 1.25. Okay, x2 again we have 1.5 plus 2 over 2 gives us 1.75. So we find all the midpoints, and for x3 we'll have 2.25, and x4 will have 2.75. Okay, after finding the midpoints, we can now find the y coordinates using the midpoints. So we have 1.25, 1.75, 2.25, 2.75. And when we replace these midpoints in this equation, the first one we get 1.7889, 1.5119, 1.333, and 1.2060. Therefore, the formula using the midpoint is 1 to 3 of 2 root x dx, and this is just the d multiplied by all the y coordinates. 1.7889 plus 1.5119 plus 1.333 plus 1.2060, and our answer will be 2.9. Okay, so this is our answer when we use the midpoint rule. Again, follow the other examples to fully understand the midpoint rule. So our final rule is known as the Simpson Row. All these rules are used to approximate integrals. Now, for the Simpson rule, here is what we okay, so here we take note that this is a parabola. Okay, these lines are not straight, because for the trapezoidal rule, we approximate this as linear lines so that we make the trapeziums. Okay, so we approximate those to be straight lines, but with the with the Simpson, we take note that these are not straight lines, but they are parabolas. Okay, so but we still have the same distances. Okay, and it's from A to B. Okay, so according to the Simpson rule, the integral from A to B of any function is just equal to 1 over 3 d, you open brackets. First you add the first and the last, y1 plus y2n plus 1. So this is the first and last. Actually, you're opening the square brackets here. Then we're going to add 4 multiplied by the even y's. Plus the odd y's. So there we have 2n minus 1, and we close the square bracket. Okay, so you just have to know we have 1 over 3 out d, then we multiply the first and the last. We add the first and last plus 4 multiplied by the even plus 2 multiplied by the odd coordinates. Okay. So let's have an example. The example, use the Simpson rule. Correct to 3 decimal places. So let's find our d. 3 minus 1 over 4, which is just 0.5. So the x coordinate, we're starting from 0.1. Then when we add 0.5, we have 1.5. Then we have 2.0, 2.5, and 3.0. Okay, so then next we find the y values. So we have x, which is 1.0, 1.5, 2.0, 2.5, 3.0. So our y So it is important to keep a number of decimal places because you're approximating. So you don't want to have few decimal places. Okay, so after this, we use now our formula. We have 2 over root 8 dx So remember, in our formula, we first put 1 over 3 multiplied by the d, which is 0.5. Then we close brackets. Add the first and the last, 2.0 plus 1.1547. After this, we get a 4 and multiply by the even. So this one was, this is y1, y2, y3, y4, y5. So the even are y2 and y4, which are 1.633 plus 1.2649. Then we get a 2, and then 2 multiplied by the odd, and in this case the odd that is remaining is just this one, because we have already used the first and the last. So the odd remaining is just 1.414. Okay. Then when we compute that, we'll find 2.929. Now, we have used the same example, same integral to evaluate or to find the area using the midpoint, the trapezoidal rule, and the Simpson rule. And we've obtained different values, but when you look critically, you find that actually they are very much similar. Okay. So again, please go through the other examples and worksheet 7, which is just based on this topic. Thank you so much and all the best.